Hi friends, welcome to Unacademy. Myself Bhavani. Students, Unacademy offers plus courses for Karnataka CET students or those who want to write CET exam in the year 2021 can subscribe the plus courses. Now when you subscribe a plus course, what are the advantages you are going to get? First of all, students, both class 11 and class 12 topics will be done in detail. There will be live doubt clearing session also. You are also given a daily practice paper. You are given full length mock tests with analysis and also quizzes for self analysis. So single subscription student, you will get unlimited access. As you can see, students here, there are different batches are available, and you will have plenty of educators will be teaching these classes. Therefore, kindly see to it that you subscribe the plus courses. You can also inform your friends, relative, brothers, neighbors related to the plus courses and help them to join the plus course. Now whenever you join the plus course, see to it that you are using the code BHAVANILIVE. Now this code will give you the discount, student. Okay, the maximum discount which is associated with this code, you can utilize it. Now we have three different plans. We have a 8 months plan. It's a comprehensive plan, and students, as you can see, you can enroll your name for this. You also have a Kannada batch which is a 6-month full syllabus batch. So in case if you are interested, you can join for this one. You can join for the Kannada batch, or you can think of joining the champions batch also. So champions batch, student, it is from 15th of October it had started. So there are different combinations, PCM, PCMB and PCB. So students, you can enroll your name for this one and try to join these batches. Okay, so whichever you feel good, whichever you feel right, appropriate, you can join that batch. And also free practice tests are available, so you can enroll your name for the tests and you can try to attempt it live and see to it that before going for the major exam, the main CET exam, you are working good number of questions that so that you are confident also, and also you are used to the, I can say, you are used to the the kind of question that can be asked, so you will be well equipped before you enter the examination hall. So students, kindly see to it that you also subscribe the YouTube channel also. Okay, and in case if you haven't watched my previous YouTube session, kindly do so. See to it that you are watching those session, and whenever you like the class, kindly press the bell icon, like button, and also press the bell icon for further notification. My next class will be on 26th, so you can join me at 2 o'clock. So see to it that all my special classes and also the previous YouTube session you are watching. Okay, so we will start with today's model question paper. I hope you are audible, student. I'm audible. Okay. See, look at the question number 1, and you can start solving, and you can give me the answer also, student. Okay, those are joined. Kindly see to it that you are going to the question. Now student, if you can see here, question number 1, the molecular weight of sodium chloride is 58.5. A solution of sodium chloride containing 5.85 gram of it in 500 gram water is. Molality is given in the option 0.2 molar, option B 0.1 molar, option C 5.85 molar, and option D is 0.5 molar. So how do we calculate? First of all, what is molality? What is molality, student? Molality is number of moles of the solute. Number of moles of the solute divided by mass of the solvent in kg. Mass of the solvent in kg. This is a formula. So we need to get a number of moles. Now how do we calculate a number of moles? Number of moles is equal to, you know the formula, mass by molar, molecular mass. Right? Mass by molar mass. And what is the mass given here? 5.85 gram. And what is the molar mass given here? Molar mass is 58.5. That means it is 0.1. Isn't it? These many moles. So you got the number of moles as 0.1. Mass of the solvent in kg. Now we have 500 gram of water. So you have to convert into kg. That becomes 0.5, isn't it? 500 grams. So in kg, 0.5 kg. So you will get 0.2 molar. So answer will be option A, 0.2 molar. I hope you understood question number 1. So we will go to question number 2, student. The normality of a solution obtained by mixing 250 centimeter cube of 0.5 normal sodium carbonate with 250 cm cube of 0.15 molar HCl is. Now you have to find out the normality of a solution. You are going to mix two, I can say acid and a base. One is 250 centimeter cube of 0.5 normal sodium carbonate, and that is mixed with 250 centimeter cube of 0.15 molar HCl. So students, look here. First of all, let us convert this into gram equivalent. How do you convert now? What is the formula? Vn by 1000. Volume is given as 250. Normality is given as 0.5 divided by 1000. Okay. So you know it is 4 times. So 0.1, you can see 2, 5. So these many gram equivalent. Now let us convert, see, sodium carbonate and HCl is reacting. So we will convert this also into gram equivalent. Vn by 1000, 250. N is given in molarity. Molarity is given, not normality. But we know how to convert molarity into normality. Students, look here. In this case, the replaceable hydrogen is only 1. It's HCl. Number of replaceable hydrogen is only 1. That means the molarity and the normality is same. Therefore, it will be 0.15 N divided by 1000. So you have 0.15 divided by 4. That will be 0.0375. Now you want to know the normality once you mix these two, isn't it? So whenever a normality of an acid and a base mixture is asked, this is acid, this is base, you know that the formula is V1N1 minus V2N2, right? Therefore, student, here V1N1 is 0.125 minus 0.0375. So if you remove this, you will get 0.08 how much 75 gram equivalent. This is the normality of a solution which is obtained by mixing these two. Now this is in how much? This is in 500 centimeter cube, isn't it? Because 250 you have mixed, so it is in 500 cm cube. We want it in 1000 centimeter cube because we want normality. Therefore, in 1000 centimeter cube, how much? So you will have how much it will be? Okay. So you will have 0.175 N. That means your answer is option A, student. Option A is the answer. Okay. We'll go to question number 3, student. Kindly go through the question and try to solve. So try to find out the, answer for this one. A gaseous reaction A plus A giving B plus 2C attains equilibrium at 500 degrees Celsius. If A dissociates to an extent of 20%, and if the final pressure is 280 kilopascal, the initial pressure would be. Okay. Now what will be the answer? See, a reaction is given. A reaction is given as A is given. Okay. A is giving B plus 2C. Okay. Then if A dissociates to an extent of 20%. Okay, so according to this equation, 1 mole of A, initially 1 mole of A is taken and number of moles of B and C are 0. When it is 100 moles, the degree of dissociation is 20. For 1 mole it is how much? Because we have taken 1 mole. For 100 it is 20. That means we are going to get 0.2. This is the degree of dissociation. So from A, 0.2 mole has been dissociated. To give 0.2 mole of B and 2 into 0.2, that is 0.4 mole of C. I hope I am making it clear. From this 1 mole, 0.2 mole has been reacted, giving 0.2 mole of B and 2 into 0.2, that is 0.4 mole of C. Correct? So whatever is remaining, how much is at equilibrium remaining? It will be 1 minus 0.2 and 0.2 and 0.4. So the total number of moles which are remaining at equilibrium is, you can see, 0.8, 0.10, 1.4. These many moles are remaining at equilibrium. Now read the next statement what is given. If the final pressure is 280 kilopascal, final pressure means When 1.4 mole is present, the pressure is 280. The initial pressure would be, what was the initial pressure? What will be the initial condition? When you take 1 mole, that is the initial condition. What is 1.4 mole? That is the number of moles at equilibrium. Once it has been reacted at equilibrium, this is the number of mole. So when it was 1.4 mole, student, the pressure was found to be 280 kilopascal pressure. If it is 1 mole, what is the pressure? So that will give you the initial pressure. So 1 into 280 divided by 1.4. Correct? Okay. So how much you will get? 20. Correct? 0. 2's are, isn't it? That means answer will be option A. 200 kilopascal pressure. The conjugate base of HCO3 minus is. Now what is the conjugate base of HCO3 minus? Whenever a conjugate base is asked, you are supposed to remove H plus minus H plus. If at all conjugate acid is asked, then you have to add H plus. Now since base is asked, you see you have HCO3 minus. You are removing only the H plus. So you will get CO3 2 minus. Therefore conjugate base of bicarbonate ion is CO3 2 minus. If they would have asked you conjugate acid, then you should have added H plus. Then it becomes H2CO3. So answer will be option A. Okay, I hope it is clear. Go to the next question, student. In the reaction, CH triple bond CH dilute sulfuric acid, X is formed. This on treating with lithium aluminium hydride, Y is formed. The compound Y is. Now how do we find out this answer? Students, if you can see here, alkyne with the dilute sulfuric acid. So there will be hydrolysis, isn't it? Water will be added. Water will be added across this triple bond. So as a result, you will be getting CH2 double bond CHOH. You are adding H here, you are adding OH here. Now you know tautomerization occurs. Therefore, you are going to get here now CH3, hydrogen migrates here, C double bond H. Now this is X. Then it is subjected to reduction with lithium aluminium hydride. What happens when aldehyde is reduced? When aldehyde is reduced, they will give primary alcohol. So you will be adding one H here and one H here. That means CH3, CH2OH. So you are going to get CH3, CH2OH. That means ethanol is formed. Alcohol. So ethanol is formed in the reaction. Okay, go to the next one. Heat of formation of aluminium oxide is minus 1660 kilojoule. The amount of heat liberated when 540 gram of aluminium burns is. Aluminium is burning. aluminium is burning and form aluminium oxide. Aluminium burns and get aluminium oxide is formed. If you balance the equation, it is 2Al. See, when I say heat of formation or when I say enthalpy change, student, it should be for 1 mole, isn't it? Enthalpy is referred to 1 mole. Therefore, we need to balance only as 1 mole here. So, 2Al. So, oxygen will be 3/2 O2. According to this known equation, aluminium, isn't it? So, how much it will be? 54 gram. Right? 54 gram of aluminium react and give 1660 kilojoule of heat. What happens when 540 gram is reacting? Now automatically you know you will be getting 16,600. Now since the question is asked, what is the amount of heat liberated? They themselves in the question they have given the heat is liberated. That means there is no requirement that you will be writing the negative sign. If they would have given you what is the heat of formation, something like that, then we have to write negative. Since they have said that, since they have asked that heat liberated, it is obviously negative sign understood. Heat liberated will be 16,600. Answer will be option C. So go to the next one. The activation energy for a forward reaction is this much. A plus B giving C plus D plus 28 kilojoule is 20 kilojoule. So the activation energy for this reaction is 20 kilojoule. The activation energy for the reverse reaction is, you can see here 28 kilojoule of heat is liberated, isn't it? If you are looking at a reaction, how much is this one now? This value is given as how much? 20. And this change is given as how much? 28, the delta H. So question is now, what is the activation energy for the reverse reaction? And what is the activation energy for the reverse reaction from here to here? That means 28 plus 20, so 48 kilojoule. Because this will be, student, this will be the activation energy for the reverse reaction, this one. So 28 plus 20, 48 kilojoule. We'll go to the next one. The correct order of second ionization potential of carbon, nitrogen, oxygen and fluorine. So students, here the second ionization potential is asked. You know oxygen is 1s2, 2s2, 2p4. Correct? Then if you take fluorine, it is 1s2, 2s2, 2p5. And for nitrogen, it is 1s2, 2s2, 2p3. And for carbon, it is 1s2, 2s2, 2p2. When you look at the electronic configuration, once you remove one electron, now for example oxygen, if you are removing one electron, the configuration is 2p3. And you know 2p3 means it is a half filled p orbital. That will be extra stable, student. Therefore, compared to any other element, Second ionization potential of oxygen will be the highest. So the possible answer is only these two. Now we will see whether it is nitrogen or fluorine. You see one electron you have removed. That means 2p4. You have removed one electron here. That means 2p2. So from this you need to remove the electron. Now fluorine is small in size. The attraction will be more from the nucleus to the outermost shell of electron. So energy required to remove an electron from F is more compared to nitrogen. Therefore, the answer will be oxygen, then it is fluorine, then it is nitrogen, and then it is carbon. So option C will be the right answer. Okay. Dissolution of ammonium chloride in water is an endothermic process. Hence, solubility of ammonium chloride in water. Option A increases with rise in temperature. Option B decreases with rise in temperature. Option C, temperature has no effect on solubility. Data is insufficient to predict the effect of temperature on solubility. So students, dissolution, when you dissolve ammonium chloride, you take water and you add ammonium chloride, it is an endothermic process. Heat is required. So since it is an endothermic process, student, as you increase the temperature, it requires the heat. So as you increase the, rise the temperature, increase the temperature, the solubility also increases. So answer will be option A. Okay, we will go to the next one. Isopropyl chloride and methyl chloride is subjected to Earth's reaction. The possible product is, you have taken student isopropyl chloride, CH3CH3Cl, isopropyl chloride, and also you have taken methyl chloride. So what are the possibilities? What are the possible product you are predicting? Students, if you can look here, one of the possibility is 2-methyl chloride, metallic sodium, Wurtz reaction. 2NaCl is removed, that means you are going to get CH3CH3. Wurtz reaction means increasing the length of the carbon chain. Alkyl halides react with metallic sodium in the presence of sodium, ether. Higher alkanes are formed. So one possibility is ethane. Another possibility is, student, with isopropyl chloride. Now you can have one more, isopropyl chloride. What happens is 2NaCl is removed. That means you are going to get CH3, CH, CH3, CH3, CH3. So this will be 2,3 dimethyl butane. So that is one more product, 2,3 dimethyl butane. Now these are, one, with the self alkyl halide, you can have one more, CH3CH3Cl plus 2Na plus CH3Cl. 2 NaCl is removed. So you have CH3, CH3, CH3. So the possible product here is 2-methyl propane. So when isopropyl chloride and methyl chloride subjected to Wood's reaction, 2-methyl 2,3 dimethyl butane is possible, ethane is possible, 2-methyl propane is possible. That means the answer will be all of the above. So I have come to the end of the end of today's session. So thank you students, thank you for participating. My next class will be on 26 exactly at 2 o'clock. If you are liking the class, kindly press the like button and also see all my previous YouTube session. And whenever you like it, kindly like them. Do not forget to share these videos among your friends. So okay students, so bye bye and take care.